Hi all, myself Dr. K. Ashok, Associate Professor of Physics, Marri Reddy Institute of Technology and Management. Today I am going to discuss about the optical fiber, which was the fifth unit of applied physics. First of all, what is an optical fiber? Optical fiber is made up of with glass or plastic, which is used to transmit the light. Where will we use these optical fibers? Basically, these optical fibers we will use in telecommunications, medical applications, and sensing systems, and illumination and imaging. In these areas, we will use these optical fibers. Why we are using optical fibers? Before optical fibers, actually we are using copper cables. Nowadays also we are using in our houses copper cables to transmit the electricity from one place to another place. But while using these optical fibers, what are the benefits we will get? See, they will transmit the signals with low loss, and here no metallic cables we have, so that electrical isolation takes place. Mainly these optical fibers we are using because of its high bandwidth. A single optical fiber can carry the bandwidth is 100 gigahertz, whereas if you use a electrical wire like copper cable for the transmission of the data, we can transmit only 40 to 50 independent isolated signals. So these are the main drawback of the copper cable. That's why we are using optical fiber. What is an optical fiber? Basically, optical fiber is a thin, flexible, transparent medium, consists of three sections. The central part of the optical fiber is called as core. Core is surrounded by a medium called clad. To give mechanical protection, it is surrounded by a plastic protection we will give, that is called outer jacket. Outer jacket plays no role in transportation of the signal. The significance in transporting the signals is mainly these two parts. One is core and another is clad. Before discussing about the importance of core and clad, first we will try to understand the refractive index. This is the major factor, plays a vital role in carrying the signal. First of all, what is a refractive index? Refractive index is nothing but the ratio of the velocity of light in vacuum to the velocity of the light in medium. Here, the velocity of the light in vacuum is always equal to 3 into 10 to the power of 8 meters per second. When we consider the medium, its speed will be reduced. This ratio of velocity of light in vacuum to the velocity of the light in medium is called refractive index. The medium having high refractive index, that is nothing but denser medium. What is the meaning of denser medium? Medium having high refractive index. And the medium having low refractive index, that is called rarer medium. Denser medium and rarer medium. In denser medium, light will travel little slower than actual its speed in vacuum. So here we are selecting core in such a way that the refractive index of the core is always greater than the clad. Core acts as the denser medium, clad acts as the rarer medium. This core and clad allows light energy to pass through it. That's why it is made up of either silica or glass or fiber material. If you use instead of optical fiber electrical cable, see here the data speed is very low, which is of 300 million per second. Whereas if you use optical fiber can transmit the data 10 gigabits per second. In optical fiber, we are transmitting the data by using light or photon speed. Whereas in electrical cable, with electron, we will transmit the data from one place to another place. While transmitting the data in copper cables, after traveling around 300 kilometers, then what happened, the speed of the electron gets reduced. Whereas if you consider the optical fiber, in optical fiber, the photon is moving, the photon speed won't affect even after 20,000 kilometers. That's why we are preferring optical fibers are more efficient when compared to the optical fibers. That's why in modern generation we replace these electrical cables with optical fibers. So this is the comparison where you can compare like electrical cable with optical cable. Bandwidth you observe very high for the optical fiber when compared with copper cable. Even the life cycle is also more for fiber optics when we compared with copper cables, because of the environmental hazards will affect our copper cable. Even rusting is also possible, whereas the fiber optics materials are made up of with glass or fiber material which won't affect environmental humidity or hazards. Now we will discuss about the basic principle of the optical fiber. Before optical fiber, we discussed about the copper cable. In the copper cable, electron will travel through copper material. Copper acts as a medium. Whereas in optical fiber, no medium is available, though the signal is transmitting from one end of the fiber to other end of the fiber. The basic principle of the optical fiber is total internal reflection. To get the total internal reflection, the light must travel from denser medium to rarer medium. Already I discussed denser medium means the medium having high refractive index is called denser medium. The medium having low refractive index, that is called rarer medium. Here you observe how the total internal reflection takes place. This is about the water. This is about the air. Water refractive index, we know that 1.33, whereas air refractive index is 1. Now see the angle of incidence. See, this is called boundary. Boundary is nothing but separation between the two media. This is the air and this is the water, and this is the air and this is the boundary. Now whatever the light ray you are incidenting, that is called incident ray. Here the angle of incidence we are changing. The angle of incidence initially we kept at 20 degrees. The angle of refraction you observe to be 27 degrees when we consider water and air. As the angle of incidence is increasing, when you reach the 40 degrees angle of incidence, then angle of refraction is 59 degrees centigrade. As the angle of incidence is reached to 48.8 degrees, what happened, the refracted ray is passing parallel to the boundary. Again, if you increase the angle of incidence beyond the critical angle, here angle of incidence is 48.8, that is called critical angle, where the refracted ray is passing parallel to the boundary. If you increase the angle of incidence beyond this critical angle, then what happened, the complete incident ray is reflected back into same medium. This is called total internal reflection. One thing you should remember here, in order to get total internal reflection, two conditions should satisfy. Condition number one, light must travel from denser medium to rarer medium. Condition number 2, the angle of incidence must be greater than the critical angle. These two conditions must satisfy to get the total internal reflection. This is the basic principle of the optical fiber. That's why in optical fiber, whatever the central part, that is called core. Core, we took the refractive index as N1, which was higher than the refractive index of the clad. N1 is greater than N2. So in the core, the light ray incident, that's why core is the denser medium and clad is the rarer medium. In order to accept the signal by the fiber, the light must travel from denser medium to rarer medium. Angle of incidence must be greater than the critical angle. If you observe perfectly about the principle of the optical fiber, okay, so consider two media. This is the boundary. This is nothing but first medium of refractive index, you take it as N1, and this is the second medium of refractive index N2. N1 is greater than N2. That means this is the denser medium and this is the rarer medium. I am incidenting the light in where from denser medium. The place where it incident, that particular place I am drawing a straight line. This is called normal. The particular place where the light ray is incidenting, there I am drawing a normal. The angle made by the incident ray with the normal is called incident angle. Now the incident ray is refracted into rarer medium as the ray is traveling from denser medium to rarer medium. The angle made by the refracted ray with the normal is called refraction angle. Now, as the angle of incidence increases, the refracted ray is moving away from the normal. That means the angle of refraction is increasing. At one particular angle, that particular angle of incidence is called critical angle. At that particular angle, the angle of refraction is 90 degrees. What is the meaning of it? The refracted ray is passing parallel to the boundary. Again, if you incident the angle of incidence greater than the critical angle, initially here it is passing parallel to the boundary, is completely reflected back into the same medium when angle of incidence is greater than the critical angle. So this is the basic principle of the optical fiber. Till now what we learned? First of all, what is the optical fiber? Optical fiber is a thin, flexible, transparent medium having three sections. Those are called core, the central part. Refractive index is denoted with the N1, and clad core is surrounded by a medium called clad of refractive index is N2. See, this is one cylinder and this is another cylinder, indirectly concentric cylinder. If you draw a line at the exactly center, that is called axis of the fiber, and this is called core, and this is called clad. Core is acting as a denser medium, clad is acting as a rarer medium. This clad is surrounded by a medium that is called outer jacket or protective skin. This optical fiber carries the signal based on the principle of total internal reflection. To get the total internal reflection, the light ray must travel from denser medium to rarer medium, and angle of incidence is greater than the critical angle. See, this is the principle of the optical fiber. Here already I told you, this is the incident ray, and this is called medium 1 of refractive index N1. This is called medium 2 of refractive index N2, and see, this is called normal. The refractive index of first medium is greater than the second medium. That's why this is called denser medium and this is called rarer medium. This exercise we are doing to calculate the critical angle. The angle made by the incident ray is called incident angle and incident ray is refracted. The angle made by the incident ray with the normal is called refraction angle. As the angle of incidence increases, angle of refraction also increases. At a particular angle, that is called critical angle, then this theta r becomes what you know, 90 degrees. For this, I want to derive this equation. See, I am applying law of refraction. What I am applying? Law of refraction. According to law of refraction, n1 sin theta I equals to n2 sin theta r. n1 sin theta I equals to n2 sin theta r. At theta I equals to theta c, theta r equals to how much? 90 degrees. When incident angle is critical angle, then refraction angle becomes 90 degrees. Then n1 sin theta c equals to n2 sin 90 degrees. We know that sin 90 value is 1. n2 equals to here n1 sin theta c. So sin theta c equals to simply n2 by n1. Theta c equals to sin inverse of n2 by n1. In the previous example, I showed you water to air. For water, what is the refractive index? 1.33. For air, what is the refractive index? 1. Then theta c equals to sin inverse of 1.33, which is approximately 48.8 degrees. So this is the critical angle you observed. So simply here you draw automatically this angle is more than the critical angle, means 48.8. That's why the incident light is completely reflected black. This is the vacuum or air and this is water. You can observe. That is about the basic principle of the optical fiber. Here in the optical fiber, different materials we have. Different materials have different refractive indices. When you consider, if you consider water, I told you the refractive index is 1.33. Water to air, the critical angle is approximately 48.75, sin inverse of 1.33. When we consider a crown glass, usually this crown glass we will use in our spectacles. Okay, its refractive index is 1.502. Then sin inverse of, how will you calculate the critical angle? Critical angle just now I showed you, sin inverse of n2 by n1. Here sin inverse of, I am considering n2 only, as n1 I will consider it as a, that's way 1. So sin inverse of 1.502, which is nothing but 41 degrees. And next you consider in the market different types of glasses are available. Two types of glasses. One is crown glass and another one is flint glass. Mainly this flint glass we will use to make prisms whose refractive index is very high. So here the refractive index is 1.62. Then its critical angle is 37.31. See, as the refractive index is increasing, automatically this value is decreasing. You can observe that one. Next, when you consider diamond, you know very well diamond glitters. Why diamond is glittering means its refractive index is very high, 2.42, so that its critical angle is 24.41, very low. That's why diamond glitters. So this is about the different materials and its critical angle calculations. So these are the references we used for making the PPT. Thank you for watching.